In this lesson, we're going to look at quadratics. And remember, quadratics are, if we look at the graph, they have that U shape. So that's actually the first point here under ways of recognizing quadratics. So this is the easiest way. They have a U shape, and that U shape opens up or down. It doesn't open sideways. So anytime you see a graph that's in the shape of a U, you should be thinking quadratic. And this whole unit, by the way, is quadratics. And so quadratics are just a type of relation between two variables that have certain characteristics, and one of those characteristics is the shape of the graph. Another characteristic is if we look at the equation always has an exponent of 2 on the variable. So we're always going to find an exponent of 2 if it's in standard form. If it's in factored form, which we'll talk about at a later date, then okay, we can't see that. But for now, we're going to just think about ones that are in standard form, exponent 2. And then if we're looking at a table of values, the second differences are going to be constant. We saw that previously that if first differences are constant, that will give us the slope of a linear graph. But if we have second differences constant, then we'll have a quadratic. So let's just run through a couple of examples. Consider the table of values below. Graph the points on the grid. Do they look like a U shape, or could they be part of a U shape? Okay, so first we're going to graph. So ordered pairs. So we'll start with the 0, 10. That's up here. Then we'll go to the 1, 3. Okay, that's right there. And then we've got two, negative 2 down here. And then just I won't highlight anymore, but 3, negative 5. And then 4, negative 6. And if I connect these together with my best curve, it's not making a U, but I could imagine extending it, and it certainly could be a U, right? If I were to keep going, it could easily go back up. So it's possibly quadratic. It certainly is part of a U. I'll highlight just the part that we had. The rest of it's just a guess. So that's the part that we had before, but it could definitely be part of a U. Could be quadratic. So what's another way I can check to be more sure? Well, I can check the table of values. I can check to see if the second differences are constant. So going from 10 to 3, we're going down by 7. 3 to negative 2, we're going down the number line. Imagine a number line going from 3 to negative 2, we're going down by 5. From negative 2 to negative 5, we're going down by 3, and then down by 1. Those are my first differences. Not constant, not linear. We already knew that because we looked at the graph. Let's do the second differences, just the differences of the first differences. So starting at negative 7 and going to negative 5, now we're moving up in the number line, and we're going up by 2. From negative 5 to negative 3, we're going up by 2, and up by 2 again. These are constant. And because these are constant, that means that we are dealing with a quadratic. Which of these relations are quadratic? Well, if we go back to how we recognize them, point number 2 at the top is they always have a highest exponent of 2. So yes, there is an exponent 2 here in example A, but is it the highest one? Well, no. We have a higher one of 3. No. Explain. Highest exponent is not 2. But for this one, we have an highest exponent 2. Well, we do have an exponent 2, and that is the highest exponent. And so, yes, that one is quadratic. The graph of a quadratic relation is called a parabola. That's a term you've probably heard before. Parabola. So that's just what we call that U-shaped graph. The y-coordinate of the highest point on the graph is called the maximum value. The y-coordinate of the lowest point on the graph is called the minimum value. There can be a max or a min, but not both. You can't have both. In this picture you can see on the screen right now, there is a highest point. Here it is. This is the highest point up here. There is no lowest point. You may think that this is the lowest point or this is the lowest point, but it really isn't, because really the graph keeps going downward. There should be arrows on the end here, in fact. These graphs keep going downward forever. There is no lowest point. So there is a highest point in this graph. If I had one that opened the other way, that opened upwards, it would have a lowest point, but it wouldn't have a highest point. So that's what this part here about being a max or a min but not both means. You can have one or the other. Estimate the maximum or minimum value of each relation and state if it is a maximum or minimum. Okay, so remember it's the y coordinate, and we just have to decide whether it's the highest or the lowest. So hopefully the highest or lowest part is easy. This is the point, and that would be the highest point, so this is a maximum. I'll just write max for short. And what's the value of that? Y equals, looks like my scale's going up by 2's, so that would be 22, 24, 25. Y equals 25. So in other words, I'm measuring it on the y-axis right here, 25. That's the highest point. And that is today's lesson.